Welcome to Mr. Honeycutt's math class. We are looking in this video at why the sine function has the shape that it does. Remember, the sine function takes as its input the radian value on the unit circle, and as the output takes the y value from the unit circle. Before we get into this, just a brief, remember 1/2 is about 0.5. Okay, rad 2 over 2 is going to be about 0.707. And rad 3 over 2 is going to be about 0.866. They're good things to have memorized. So, now for these. So the sine of 0 is 0. There's that one. The sine of pi over 6 is 1/2. That's right there. The sine of pi over 4 is rad 2 over 2. That's going to be, pi over 4 is going to be right about there. And it's set 0.7, so it's almost like 3/4 of the way. Sine of pi over 3 is rad 3 over 2. It's going to be about there. And then the sine of pi over 2 is 1. Put that there. Sine of 2 pi over 3 is going to be rad 3 over 2. It's going to be right about there. Notice I'm trying to make these about even, about 0.866. Rad 2, sine of 3 pi over 4 is rad 2 over 2. And the sine of 5 pi over 6 is 1/2. It's going to be about there. And the sine of pi is 0. Sine of 7 pi over 6 is negative 1/2. Sine, and then there's the sine of pi over 4 is negative rad 2 over 2. Right about there-ish. Negative rad 3 over 2 is going to be somewhere around there. And 3 pi over 2 is going to be negative 1. Right about there. At 5 pi over 3, it's going to, the sine of 5 pi over 3 is negative rad 3 over 2. Right about there. At 7 pi over 4, it's negative rad 2 over 2. Remember, this one's the one that's in the middle. And then 11 pi over 6, it's negative 1/2. So it's about there. And then at 2 pi, it's 0. And then if we connect the dots, we get the waviness that is the sine function. Ta-da! Connect the dots. So, a couple things to notice. One, notice that sine starts at 0. A way to remember this, and the difference is sine starts on the slope. Okay, it starts in the middle. It starts on the slope of the hill, on the side. Okay, now looking ahead at left-in behavior, notice it's periodic, so it's there is no left-in behavior because it doesn't actually settle. The domain for sine is all reals because it keeps going over and over. It has increasing intervals. If you'll notice, like an increasing interval, it's increasing from here to here, and then that repeats. Okay, so it is increasing from negative pi over 2 to positive pi over 2, and then that keeps repeating. So you'd have to show more than one interval. So, and then it's plus pi, plus some pi times k, plus some pi times k. There is maximums here and here at pi over 2 plus some pi times k. There's, because it's a repeated maximum, right? It's decreasing on this intervals and so on, which would be from pi over 2 to 3 pi over 2. And again, both of these are plus sometimes some pi times k. Remember, these are interval notations, not points. Okay. There is a minimum, let's see right there, at 3 pi over 2 and multiples of pi times k. Where's that 2k? 2 pi k. Yeah, because there's a full period. This is actually a 2 pi k, and this is a 2. We're going to get into like what's going on with that soon. The range in this case is from -1 to 1. Because it only goes from -1 to 1. And the right-in behavior, there is no right-in behavior because it's periodic. It's just going to keep going up and down, circling around forever and ever. Now, let's look at, I'm going to move that out. Let's look at the cosine function. For the cosine function, again, the input is the same. It's the radians, but the output is the x value from the unit circle. One of the things I think that's tricky to understand about the cosine function is, remember, this x in function notation means input, whereas the output is the x value, the x coordinates on the unit circle. Those are different kinds of x values. This is an input kind. This is like a location on the unit circle kind, which is kind of, I mean, it's confusing. So looking at my cosine values, hey, I've got several right here. So pi over 2, the cosine of pi over 2 is 0. The cosine of negative pi over, that's 1/2. This is rad 2 over 2. This would be rad 3 over 2 for a cosine of negative pi over 6. And the cosine of 0 is 1. The unit circle starts at 1, 0. So, and there it is right there. So the cosine of pi over 6 is rad 3 over 2. That's going to be somewhere around there. Cosine of pi over 4 is rad 2 over 2. Cosine of pi over 3 is going to be 1/2. And the cosine of pi over 2 is 0. Cosine of 2 pi over 3 is going to be a negative 1/2. The cosine of 3 pi over 4 is going to be negative rad 2 over 2. Somewhere, that's in the middle, so it's somewhere around there. And the cosine of 5 pi over 6 is going to be negative rad 3 over 2. So that'll be almost there. And the cosine of pi is going to be negative 1. So the cosine, moving forward, cosine of 7 pi over 6 is negative rad 3 over 2. The cosine of 5 pi over 4 is negative rad 2 over 2. Remember, that one's in the middle. Okay. And the cosine of 4 pi over 3 is negative 1/2. Cosine of 3 pi over 2 is 0. Cosine of 5 pi over 3, notice we're in quadrant 4, so we're positive again. It's going to be positive 1/2. Cosine of 7 pi over 4, that's the one in the middle. It's going to be rad 2 over 2. About right there. Cosine of 11 pi over 6 is about rad 3 over 2. And the cosine of 2 pi is, again, 1. And now we've returned, and hey, rad 3 over 2, rad 2 over 2. And that just keeps going, by the way, 1/2, and then 0. Hey, look, those are those values. Right here. Connecting my dots, connecting my points. It has the same wavy shape as a sine function, but the key difference is where it starts. And one way to remember this is the cosine starts on the crest. The crest of the hill. It starts at the top of the hill. When we're doing curve fitting stuff, as we will be doing, sometimes easier to use cosines because it's often easier to identify maximums and like figuring out things from max to max. So the left-end behavior is, again, isn't happening. Same thing with the right-end behavior. Okay, the domain, as this one is, again, all reals. Notice the increasing intervals are going to be different intervals. Okay, it goes, in this case, it'd be from pi to 2 pi. Okay, it's increasing. And so forth, and then again, plus, I believe it's 2 pi. Yeah, plus 2 pi. 2 pi k. The maximum for the cosine are here and here, so that's at 0 plus 2 pi times some constant k. Okay, where k is an integer. This is how we denote, by the way, these like periodic things. Like, I mean, it's got more than one maximum. How do you keep talking about it keeps going? Well, we can use this notation of 2 pi times k, and then we'll even do that thing where we say k is an integer. We've got that goofy looking e and then the weird looking z. That just means it's an integer. So it's just positive or negative whole number, just a positive or negative whole number multiple of 2 pi. Now we're just, yeah, that's all that means. Okay, it's decreasing, from 0 to pi. And then again, all of the other intervals. All right, but that's one of them. And then it has a minimum here at pi. And again, some other 2 pi equals 2 pi times some other k. And the range, the values, just like sine, only go between -1 and 1. So those are the x values. So let's be, the max, by the way, would be 1, and the minimum would be -1. So that's the cosine function. Notice the differences when there's positives and negatives, so on, when it's increasing, when it's decreasing. The main thing I want you to get is the basic shape. If it has a wavy thing where it's like, it's a cosine or a sine function. It's important to remember that these shapes come from the unit circle. That's why they have the shape that they do. The waves are created by some sort of rotating thing. This is why anytime in the real world that you have anything that's rotating in some ways, usually you're going to have pi involved, and you're going to have sines and cosines and maybe tangents involved, because there's some kind of rotation. So that's why if it's making some sort of circle, it's probably going to have a sine and cosine involved. So that's why these the sine and cosine functions look the way they do.